To measure current, we use an ammeter. An ammeter must always be connected in series. Why is that? An ammeter also must have very low resistance. An ideal ammeter has zero resistance. Why is that? On the other hand, a voltmeter, which will measure the potential difference across a component, must be connected in parallel. What can you say about the resistance of an ideal voltmeter? Why? Look at the two values. Can we work out the resistance of the lamp? So we have a potential difference of and a current of. What is the resolution of the ammeter? What is the uncertainty in this value? What is the percentage uncertainty? Here we have the same setup as before, but the digital voltmeter has been replaced with an analog voltmeter. Let's look carefully at the scale. So it says connected at its most sensitive scale, 0 to 5 volts. And there is the screen showing the potential difference. How do the two compare? Are there any advantages, disadvantages in using the digital voltmeter compared to the analog voltmeter? Some analog voltmeters have a little mirror behind, let's say, the needle. Why do you think that is the case? What is the uncertainty in this measurement? Remember, we're using a scale of 0 to 5 volts. So look carefully at the reading, identify the resolution, hence the uncertainty, and then you can find the percentage uncertainty. Here you can see two analog meters, a voltmeter and an ammeter. As you can see, there is a little mirror behind the point of the needle. What is the function of that mirror? Look carefully at the ammeter. Nothing is connected, but it shows a non-zero reading. What kind of error will that introduce? How can you correct for this error? Resistivity is a key property of the material. If you have a metallic wire, in this case we have nichrome, there we go, how can we calculate its resistivity? What do we need to measure? Look at the formula for the resistivity and think, how would you measure the relevant quantities? The formula requires that we know the length. By putting the wire on a ruler, as shown, that makes it easy. What do you think the function of the copper contacts are? How do they improve the method? Make it more accurate? Looking at the two ends, what is the length of the wire under consideration? We also need the resistance. We could use an ohmmeter connected in parallel, and as you can see, it says 15.7, 15.8 ohms. Here we go. What else do we need? How do we measure it? Can you suggest an appropriate method to improve the accuracy in the measurement? We need the area. How can we find the area? What shape is the wire? Be careful to state what we measure. So we have length, we have resistance, and using a micrometer, we can measure the diameter. Be careful, we cannot measure radius directly, we measure the diameter. What is the resolution of this micrometer? What is the uncertainty? How will you use it to obtain an accurate value of the diameter of the wire? How can we adapt this method so we can use a graphical method instead of one calculation, to work out the resistivity of Nikon wire? Why is the graphical method better? Instead of using an ohmmeter to find the resistance of the wire, we can use a voltmeter-ammeter method. Remember, the ammeter has to be connected in series, the voltmeter in parallel, and where necessary, you need to choose appropriate scales. So I'm using a 9-volt battery, so I should opt for the 20-volt scale. So this is the same setup shown before. What is the function of the fixed resistor? Why do I have it there? Let's just switch on so we can see that the meters are reading the voltmeter 6.0706 volts, and we can see that the ammeter is reading 0.376 amps. What can you do to ensure that the method will lead to an accurate value of the resistance of the wire? This setup will only give you, for a given length, one value. Of course, we can vary the length and record current and voltage, potential difference for each length, work out the resistance, and come up with a graphical method for finding resistivity. Again, we will need to also know the area, which we can find by measuring the diameter of the wire. This shows a variation of the previous setup with the introduction of a variable resistor, a rheostat. We can use the variable resistor to change the total resistance of the circuit and hence the current flowing for a given potential. In this variation, for each length of the wire, we adjust the variable resistor so the current is always the same. Why is this a useful, appropriate method? How can we analyze this data? So remember, for each length, we can record the potential difference, the length, the current stays the same, so we adjust the variable resistor until the current goes back to this value. And as before, we also know, using a micrometer and an appropriate technique, the diameter of the wire, so we can find the radius, diameter over 2, pi r squared the area, or pi d squared over 4 direct. Remember, you can only measure diameter. Again, I have a fixed resistor here. What is the function of that fixed resistor? Why is it beneficial to have one? Here we have some resistance paper. It has a very thin layer of graphite on it, and our task is to find the thickness of the graphite layer. Now you can assume that the resistivity of graphite is given. What measurements do we need to make? Can we come up with a method that involves a graph? Why is a graphical method always better? So let's look at the potential setup. So here I have my resistance paper fixed on a board. It's in the form of a rectangle. I have 2 electrodes, copper, and to ensure good contact, I have put a piece of wood and some weights on each one. I can change the length between the electrodes. How can I measure accurately the length? What is the resolution of my ruler? What is the uncertainty? Assume I put the ruler like that and try and line it up. So I read where the first electrode is and where the second one. And then I work out the length that I'm using by subtraction. What would be the uncertainty in that length? I also need the width of the paper. Now I can easily see that, although it looks like a rectangle, perhaps it's not a perfect rectangle. So how can I measure the width accurately? Can I use any other piece of equipment, standard equipment, in the lab to ensure that I can take measurements as accurately as possible? How about the set square? Should I measure the width once? Can I do better than that? What else do I need to know for each length? So remember, we can record the length, the width, and for each length, by connecting an ohmmeter in parallel, we can work out and record, as you can see, the resistance. So let's assume we repeat this for different lengths. The width, of course, is constant, or at least the average width is constant. And for each length, we have a resistance. We know the resistivity. How can we use this data to work out, using a graph, the thickness of the graphite layer?